Sometimes when people find out I'm a mathematician, they've got a question to ask me about maths. And the most common one I've had is, why is minus 1 times minus 1 equal to 1? So this is my attempt to explain this. I'm going to give two explanations, one in terms of real world phenomena and the second in terms of mathematical principles. So first, let's think about what minus numbers or negative numbers are. For many people, the first way you see these is in something like temperature. We say, okay, we measure temperature with numbers and we have a temperature of 0, but it can actually get colder than this. So we invent some new numbers where we sort of count downwards, and these represent temperatures which are colder than 0. So this is a good way to get started, but it's not the best way to think about it in terms of what we're going to do next. So two better ways are in terms of height or distance and in terms of finance. So if we want to think about height or distance, one way you can think about this is if we want to measure height on the Earth, then the ground varies in height. So if we want a consistent way to do it, we might measure the distance above sea level. So if we want to then go down into the ocean, right, that's not above sea level. So we could, again, sort of count downwards from 0 and use these minus numbers to measure distance below sea level. And so if you're 1 meter below the sea, then we could say that you're minus 1 meters above sea level. Another one is in terms of money, right? If you have some money, we can measure that with numbers. But if you owe someone else some money, then we could say that's like, we can use minus numbers to represent this. Right? If you have a debt of £10, we could say your total wealth is minus £10. Okay, so let's think about these a bit more. Before we get to multiplying minus numbers, I want to think about adding them. Okay, so note that this is quite easy. You just sort of do what you expect, right? If we're 100 feet below sea level, so that's like a distance of minus 100, and we get in some rocket and fly up 1,000 meters, then we're going to end up 900 feet above sea level. Okay, we just take away the 100 from the 1,000 to get the 900. Okay, the same thing works with money. If I have £50 in my wallet, but I owe my friend £10, then my total wealth is £40. Again, I just take away the 10 from the 40, and that's how I work out what it means to add a positive number and a negative number. And I could do this with two negative numbers as well. If I owe two different people £10, I have a total wealth of minus £20. Okay, the next thing to notice is that we can also multiply positive numbers by negative numbers. Okay, and we do this just in the same sort of way we'd expect. Well, if I have 5 lots of £10, I have a total wealth of £50. If I have 5 debts of £10, I have a total debt of £50. So 5 times minus 10 is minus 50. Again, this is nice and easy and sort of makes sense. But it's more, we can't extend this idea to multiplying together two negative numbers, right? If I say I have minus 5 debts of £50, that doesn't seem to make any sense. So what can we do? Well, I want to think about distance, right? So say I'm traveling along a road, which in the picture is curvy, but maybe you imagine it's straight. This is a picture of Norwich. Say I'm driving to Norwich and I'm measuring how far I've got left to go. And I get, I've got 30 miles to go, 20 miles, 10 miles. And then I get there, but I forget to stop driving and I carry on going. Again, we've gone past 0, so we might start using minus 10, minus 20 if I keep driving away in the opposite direction. So let's think about this in a little toy example. Here I've got a picture of a little toy car, which is meant to be very small, and it's driving along a road past the flag, and we want to measure how far to the right of the flag it is. So I've said it's 20 centimeters to the right of the flag. Okay, so we can have positive and negative numbers now. Positive is to the right of the flag and negative is to the left of the flag. And I can add things, right, in the usual way. If I want to add a number, I drive to the right. If I want to take something away or add a negative number, I drive to the left, or reverse. But multiplication doesn't seem like a natural thing to do. Right? I can double my distance if I drive another 20 centimeters, but this won't work if I try and do it again, right? Really, I'm not really doubling, I'm really adding what I had before. So when would we multiply in a situation like this? It doesn't seem natural. But there is one situation where we do multiply. Okay, if maybe you don't like centimeters but you like inches, right, we can convert between these. There's about 2.5 centimeters in an inch. So if we multiply 8 by 2.5, we get 20. If we multiply 20 by 0.4, we get 8. So we can convert between different measurement systems by multiplying. Okay, that's what multiplying means in terms of distance. It doesn't change where you are, it changes how you're measuring. Okay, so now we can start to bring in negative numbers. Right, if I multiply by -1, you know what's going to happen here, right? From the examples we had multiplying a positive by a negative number. If I multiply by -1, I'm really changing my measurement system. So now I'm measuring to the left of the flag and I get -20 centimeters. Okay, and note this swaps round which is positive and which is negative in terms of left and right of the flag. Okay, so if I do this twice, then I'm going to get back to where I started. But if I swap left and right, I swap left and right again, I get back where I started. So this is the best explanation I could come up with in terms of sort of physical phenomena of why multiplying by a negative number twice will give you a positive number. So maybe you found that satisfying, maybe you didn't. Let's try another way. Okay, so I'm going to ask again, why is -1 times -1 equal to 1? And now I don't want to think about interpreting this in real world things directly. I want to think about the properties of arithmetic, and I will give some real world examples to justify these. But if we have these negative numbers, we really want them to work in the same way the positive numbers do. Otherwise, it's going to like break all our notions of maths. Okay, so let's think about what are the rules that we want to work when we do arithmetic, right? When we multiply things and add things. Okay, so I'm going to give you 4 rules, which I hope you'll agree, sensible rules that make a lot of sense, that we use a lot, and that we want our number systems to follow. So the first rule is a nice easy rule. Any number times 1 is just the same number. Okay, we can think about, so I'll try and demonstrate this in terms of putting apples in boxes. Right? If I have 1 box containing 5 apples, then I just have 5 apples. Right? I'm not counting boxes here, I'm just counting apples. 1 box of 5 apples is just 5 apples. So my first rule, anything times 1 is 1. Okay, now my second rule, which is also quite easy. Anything times 0 is 0. Okay, if I have 5 boxes, all of which contain no apples, then I have no apples. Okay, so this is sort of illustrating that 5 times 0 is 0. Okay, so first 2 rules seem quite simple. Multiplying by 1 leaves it the same. Multiplying by 0 makes it 0. And now the third rule. So the third rule is about negative numbers. This is it. And it's basically the only thing that we know about negative numbers, right? If I've got the number -1 and I add 1 to it, I should get back to 0. You can actually think of this as the definition of -1. So yeah, if I have £1 in my wallet, but I owe someone £1, then my total wealth is 0. Okay, so this is my third rule. There's one more to come, which is probably the most complicated one, but it's not that bad, and you've probably seen it before. So the final rule is a combination of adding and multiplying. It uses both of these things. So say I'm going to add together some combinations of apples. I've pictured them as green apples and red apples. So I've got 3 green apples and 2 red apples. So I can add them to say in total I have 5 apples. And now I'm going to multiply it. Right? I'm going to take my combination of 5 apples and I'm going to multiply it by 4, which I've pictured by having 4 crates with the same types of apples in it. And okay, you can count these up. I have 20 apples. Right? So I have 3 and 2. I add them to get 5, and then I multiply by 4 and I get 20. Okay, so but there's a different way I could do this. Right here, I added them first and then I multiplied. I could also do it the other way around, and I could multiply first and then add, as long as I'm careful to do it the right way. And the thing is, I need to multiply both of my numbers before I add it. Okay, so here's the picture. I can do what I did before and sort of combine my apples and then have 4 crates of them. Or I could just have 4 crates of my 3 green apples, and I could have 4 crates of my 2 red apples, and then I could add them. Okay, so in school, we sometimes learn how to go back and forth between these and call it simplification or factorization. So the important thing is if we multiply 2 numbers added together, we can actually do the multiplication first, as long as we multiply both numbers. Okay, so yeah, there's the picture. And this is my 4th and final rule. Okay, so let's just remind ourselves of the 4 rules. The first one was that anything times 1 is the same thing. The second one is that anything times 0 is 0. The third one was that 1 plus minus 1 is 0. And the fourth one was this rule that says I can, if I add 2 numbers and then multiply, I can actually multiply both of them by the number and then add them. Right. Now we've got those in our head, we can get to the punchline. So we start with the only thing we know about minus 1. Okay, 1 plus minus 1 is 0. This was my third rule. And now what I'm going to do is I'm going to multiply both sides of this by minus 1. Right? If the thing on the left is 0 and the thing on the right is 0, then if I multiply both by minus 1, I should get the same thing. This might seem a bit silly. You might wonder why we're doing it, but let's just stick with it a minute. I'll just write it down. Right, so I've multiplied both sides by minus 1. I haven't written a multiplication sign, but I've written them next to each other to denote multiplication. Okay, so now you can see straight away that we can use another one of our rules. Maybe the right side is most obvious. I've got something times 0 on the right, so that's going to end up as 0. And on the left, I can use my 4th rule, when I'm adding 2 things and then I'm multiplying. So I can simplify this. I can multiply both numbers by the thing I'm multiplying by and then add them together. So let's do both of these. You can see on the right hand side I've changed it to 0, and on the left hand side I've expanded out the multiplication. Okay, great. Now you can see that I can use my first rule, which I hadn't used yet. Anything times 1 is 1. Okay, and we want this to work with negative numbers as well. If I have 1 debt of £1, I have a wealth of minus 1. Okay, so I'm going to simplify this thing on the far left. Minus 1 times 1 is minus 1. Okay, so that's my equation now. Minus 1 plus minus 1 times minus 1 is 0. You can see we're getting close to what we want to know. And to finish off, we just add 1 to both sides. Okay, and I know that the minus 1 and the 1 are going to cancel out, right, by my third rule. And I'm going to get 0 plus 1 on the right, which is 1. And there we go. We get minus 1 times minus 1 is 1. So to get here, we've just used the normal rules of arithmetic. If we want negative numbers to satisfy them like positive ones, then we must be led to this conclusion.